Moles is probably everybody's favorite concept to learn about in science, so we'll review moles very quickly and then we'll turn our attention to molarity. On the left of the screen we have an image of 1 dozen eggs. When you use the term 1 dozen, you always mean that you have 12 of something. The term 1 mole works in much the same way. Just like the term 1 dozen means that you have 12 of something, the term 1 mole means that you have 6.02 times 10 to the 23rd of something, and we call that number Avogadro's number. With that quick review, we'll turn our attention to molarity, and we'll use sucrose in our example since we've been using it throughout the presentations. The molecular weight of sucrose is 342 Daltons per molecule. We know that we need 6.02 times 10 to the 23rd molecules to get 1 mole of sucrose. But there's no way that we can count out 6.02 times 10 to the 23rd molecules. So how do we find 1 mole of sucrose? The way that we do this is by using mass. But how many grams of sucrose do we need to get 1 mole? We determine that by using the molecular weight. We have 342 Daltons per molecule of sucrose. We also know that there are 6.02 times 10 to the 23rd molecules per mole, and in 1 gram of any element there are 6.02 times 10 to the 23rd Daltons. Now if we work through this equation, we can cancel out molecules, Daltons, and Avogadro's number, and that will give us 342 grams per mole of sucrose. If you notice, that is the same number that we use for the molecular weight. And that's a general rule that you can apply to any molecule. If you take the molecular weight of a molecule and take that same number in grams, that will give you 1 mole of that substance. Now we use moles to illustrate how to make different concentrations in solutions. Molarity is a way of expressing concentrations as a number of particles, and by definition, molarity is the number of moles of solute per liter of solution. A 1 molar solution is 1 mole of solute per 1 liter of total solution. The way that you make this is not to add 1 mole to 1 liter of water. That would give you a concentration just under 1 molar. So you take about 80% of your desired final volume, and in our case that would be 0.8 liters. You would add 1 mole of sucrose, which would displace the water slightly and raise the volume, and then you would add water until you reach your desired total volume of 1 liter. This would give you a 1 molar solution. If you wanted a 2 molar solution, then you would need 2 moles of solute per 1 liter of solution. You would make this in the exact same way, except instead of adding only 1 mole of sucrose, you would add a second mole, or 342 more grams of sucrose, to a total final volume of 1 liter of solution. And to prepare any concentration of solution, you would use these same general rules.